Hello, everybody. Welcome to my first video for this class. So please be patient with me. This is one of the first times I'm trying to do this screencasting thing, and so hopefully it'll work out for us. I realize a lot of you, or actually all of you, won't have a paper copy of these notes necessarily in front of you, but I figured at least you can always pause this video, rewind it, come back and watch it later, and feel free to just have any kind of paper and pencil by you, and you can write down any notes that you think are helpful. I have put the final answer key version of this on the Google Classroom already for you, so in a sense you don't have to worry about writing things down, but I know that a lot of learning happens by writing. So if you have even a piece of scrap paper and you just start writing things for practice, it may still be helpful for your learning process. And I apologize for the lighting. I'm backlit right now through my windows, and so I'm trying to light myself from the front, so I've got this big beaming light in my face, but hopefully that means you can see me a little bit. I thought it was just a little bit more of a personal touch than just watching a video, so hi to all of you. Okay, so this next chapter that we would have started would be rational expressions. And the root word of rational is ratio, which is kind of a word for a fraction. So this is a fancy word for fractional expressions. However, at the pre-calculus 20 level, we're not talking about simple fractions like 1/2 or 4/5. We're talking about fractions that involve polynomials and variables in them. Okay, so that's the focus of this unit. We're going to start by working just with rational expressions themselves and simplifying them. Our next section will be on multiplying and dividing them. Then we'll work with adding and subtracting them. And then we'll finally work with solving equations that involve rational expressions. Okay, so 6.1 is just on the expressions themselves. Here we go. Many day-to-day applications use rational expressions. When we take a road trip, we can determine how long it will take us to get to our destination by dividing the distance. We have to travel d by our speed at which we are traveling r. So here's the ratio that I was talking about. This calculation allows us to determine our estimated time of arrival. So DEFN stands for definition. So the definition, a rational expression is a ratio of polynomials p over q, where q cannot equal 0. So that's kind of the most important part here. And we're going to talk about non-permissible values in a minute here. And that means that values that aren't allowed in our expression. And where those come from is they are the values that create a denominator of 0. So here's some examples of the types of rational expressions you will see in this unit. The only thing we have to be careful of is that our x or y value, or whatever variable we're using, will not create a denominator that's equal to 0. As we know, we cannot divide by 0 mathematically. It is impossible. And so therefore, we have to make sure we avoid that situation. So one key idea, the first one in this section, is about non-permissible values. Whenever you're working with rational expressions, it's important to determine any values that must be excluded or not allowed to be part of our numbers that we're working with. So what happens in each of the following expressions if you put x equals 3 in? Okay, so let's see what happens if I substitute a 3 for this x and for this x. So I've got 3 minus 7 on top, and then I have 3 minus 3 on the bottom. So I end up with -4 on top, but 0 on the bottom. So that is a problem. That is not allowed. We call that undefined in math when we're dividing by 0. And so we get an undefined expression, which is a big no-no. Okay, let's say we put a 3 in for x here. Then we would get 3 minus 7 on top again, and then 3 squared minus 9. So 3 minus 7 again gives us -4. 3 squared is 9. 9 minus 9 is 0. So once again, we've got the -4 over 0, which is undefined. Again, not allowed. Okay, let's take a look at C. Putting in a 3 for x once again. So on the top, I have -4, and on the bottom, I have 9 minus 12 plus 3. 9 minus 12 is -3 plus 3 equals 0. So I've got a problem yet again. I have another undefined answer here. So looking below, what is the result when 0 is divided by a non-zero number? So if the 0 is on top, like this, 0 minus 9, that's actually okay. We're okay with that. We just get an answer of 0. But why is it undefined when 0 is in the denominator? It's because it is impossible to to calculate. Pardon me. I'm just going to erase that. I forgot to write my answer was undefined first before I explained. And it is impossible to calculate. And I'll explain what I mean. So if I bring 0 donuts to class and I divide it among 9 students in my class, each student gets 0 donuts. So that is okay. But if I have 9 donuts and I try to divide them up amongst 0 students or put them into 0 piles, that is impossible to calculate or do. So that is why that is undefined. So let's look at these examples and determine what the non-permissible values are in these examples here. So for example, with A, what would be the value of X that we, actually I'm going to write it a different way, pardon me. What's the value of X that would not be allowed for this expression? So what could I put in for X that when I multiply it by 5, I get 0? So you can set the denominator as a little mini equation equal to 0. So 5x, actually we'll say it can't equal 0. I'm going to divide each side by 5. And so I get that x cannot be 0. For question B, I'm going to create a little mini inequation. I'll say the denominator here, x minus 7 cannot equal 0. I'm going to add 7 to each side, and therefore x cannot equal 7. Looking down at C and D. C, we have 2 polynomial factors or 2 binomial factors, so I have to set each of those not equal to 0, kind of like what we did in chapter 4 when we were solving our quadratic equations. So this time I have to do an x minus 5 can't equal 0 over here, and I have to do a 2x plus 1 can't equal 0 over here. So I'm going to have more than one restricted or non-permissible value. So here I get x can't equal 5. And here, first I'm going to move the 1 over, then I'm going to divide each side by 2. So here I have 2 restricted values, so x cannot equal 5 or negative 1/2. And so I'm going to write that kind of like in my set notation, except to make sure that I'm saying that they can't equal 5 or negative 1/2. Okay, let's take a look at D. D looks very similar to C, where we have a more complicated denominator, except this one hasn't been factored yet. So we're going to make it look like question C by factoring it. So thinking of 2 numbers that multiply to make negative 10, but add up to make positive 3. And those 2 numbers would be positive 5 and negative 2. Then I have to come up with my mini inequalities here. And I know that my non-permissible values are going to be negative 5 and 2. Sorry, I have a mistake in my notes, but these look right to me on the screen. Okay, so we would have x can't equal negative 5 or 2 for that expression. Let's take a look at a few more. So for E, again, we can factor this one. This one is the difference of squares. So we would factor to be x plus 7, x minus 7. By the way, did you notice I'm completely ignoring my denominators? Or pardon me, ignoring my numerators. It's only the denominators that are giving us our non-permissible values. So x can't equal negative 7 or 7. Here we have 2 restrictions, but basically B can't be 0 and C can't be 0. So the 2 restrictions refer to the 2 different variables, but if either one of those is 0, it would eliminate the entire denominator. Here we have 4x minus 8y. We can factor out a GCF and then do our little looking at each factor separately. The 4, we're not going to get anything from that, so there's just nothing to come of the 4. It's a constant. There's no variable involved there. This one's a little bit more complicated because I'm going to set up my little mini equation, I'll call it here, because I know that x minus 2y cannot equal 0, and that's actually the only way I can state this. I can't really take it any further. Some people might say, can't you say x can't be equal to 2y? Sure, you can write it that way, but these are both good ways of showing the restriction here. So what would the rule be for explaining how to determine non-permissible values. Pardon me. Okay. So I'm going to try typing. It's a little bit neater than my writing. The first thing you want to do is factor your denominator. If possible, factor. And then you want to determine the value that would make each factor 0. And those would be your non-permissible values. Okay, so that's the first key idea. The second key idea when we're working with rational expressions is simplifying them. Okay, so you have experience with simplifying already because you've simplified fractions in the past. For example, any number divided by itself is 1. So for this example, we have 3 divided by 3, so that becomes 1. Now that still holds even if we have polynomial numerators and denominators. So here we have x plus 3 over x plus 3. So that is 1. The only thing we have to say here is that in this example, x cannot equal -3, because if I put a -3 in here, I'm going to get a denominator of 0. So we just have to make sure we're writing what those restrictions are. Now, what about simplifying 7 divided by -7? Well, a positive divided by a negative is going to be negative. And so 7 over 7 is 1, but we have a -1. That's because 7 and -7 are called opposites. So what if we have opposite polynomials or binomials? For example, x minus 3 and 3 minus x. Those are considered opposites. And this is a typo. It should say its opposite. So any rational expression divided by its opposite is -1. In this particular scenario, what's the restriction on x? 3 minus what would give us a 0? And so here the restriction is +3. Okay, so let's state what the opposite is of each of these numbers. So I have 2 minus x. So its opposite would be x minus 2. The opposite of -2a plus b is going to be 2a minus b. So to find the opposite, you can think about multiplying your expression by -1. Or some people like to think of it as dividing by -1, which would be like factoring out a -1. Either one, it's doing the same thing. When we multiply or divide by a negative, we're changing all the signs. So here we had a 2 that was positive, but now it's negative below. We had an x that was negative, now it's positive in the opposite. So here we change the signs of each. Here, the opposite of -5x minus 2 would be +5x plus 2. Okay, so let's practice on reducing these questions. Now, some are easy and some are actually trickier than they seem. So you really have to watch. So the question is how is my numerator related to my denominator in this question? Are these the same? Are they opposites? Or are they neither? So 2x plus 3 and 3 plus 2x. Are those the same or opposites? Well, when we add, the order doesn't matter. So I can rewrite this bottom part as 2x plus 3. So 2x plus 3 divided by 2x plus 3 is 1. They are actually the same. Here, 5 minus x and x minus 5. Well, this time we have opposites. So the answer is going to be -1. If we see that in a question, we can simplify that to be -1. What about here, 7x plus 1 and 7x minus 1? Let's see what happens if I take my bottom factor and multiply it by -1, and I distribute that -1 to each piece. I get -7x plus 1. But be careful, this was a +7x, and I ended up with a -7x. So this one actually can't be reduced. They're not the same, and they're not opposites. So it's tempting to think that those are opposites, but you have to be really careful and maybe even do a little side calculation to check that out. Okay, on to the next page here. We're on page 3 out of 4. So rational expressions can be simplified, and that's what we're going to do here. So if I just scroll up, by factoring the numerator and the denominator, determining any non-permissible values, and dividing out anything that's the same common factor or what we call opposites. Okay, so let's take a look at example A. We have 15m cubed t over 5m squared t to the fourth. Now it's already basically factored. It's not a binomial or a trinomial, so there's nothing more we can do. This is good old-fashioned reducing like you would have done in grade 9. So this is actually kind of a grade 9 question here. 15 divided by 3, or 15 divided by 5 is 3. M cubed over m squared is just 1m, and it's left in the numerator. This is a little bit thick, so I better get rid of that. Oh, that got rid of that too. So I'll write my m again. No worries. So I have 3 minus 2 is 1. So I have 1m and it's in the numerator. Now I have 1t in the numerator and 4 in the denominator. So I'm going to end up with 3 remaining in the denominator. So one of my t's here cancels out with one of them here, but I still have 3 left. Okay, let's move on to an example that's more at our level of pre-calculus 20. So what I'm going to do here is factor. I'm going to factor the top and the bottom to see if I have any common factors that can cancel or any opposites that can cancel. So my top is actually a difference of squares. It looks like there's only 2 terms there, but it is a perfect square minus a perfect square. So I have x plus 1, x minus 1 as the factoring of the numerator. In the bottom, I'm going to have x plus 2, x plus 1. 2 times 1 equals 2. If I do my rainbow check, I get 2x and then another 1x. That gives me a total of 3x. So I know I factored properly. Now the question is, do I have anything that can cancel? And I have x plus 1 and x plus 1 that are identical. Whenever I cancel something, I'm left with 1s. Not nothing, not zeros, 1s. Now, can I cancel the x minus 1 with the x plus 2? Absolutely not. Those are not the same. So what I end up writing is x minus 1 over x plus 2 as my final answer. But I also have to state as part of my final answer my non-permissible values. Now, non-permissible values are anything that at any point along the way could have made the denominator 0. So I don't just look at my answer for my non-permissible values. I look back here to find the NPVs when my denominator was factored. And so I actually have 2 non-permissible values here. Because of the first factor, x can't be equal to -2. Because of the second factor, x can't be equal to -1. So this is actually part of my answer in this unit as well. Probably should have circled it all together actually, so I'll try and do that on the next question. Okay, so let's take a look at C. Okay, I'm going to try and factor the top. Now I do have the ability to factor the GCF here. So if I factor a GCF of 3, I get 3 times 4 minus x. And then in the denominator, I have a trinomial and it is factorable. So I have x plus 5, x minus 4 as my 2 factors there. Now I need to see if I have any common or opposite factors. And I do. 4 minus x is the opposite of x minus 4. So I'm going to go ahead and cancel these off. But what am I left with? I'm left with a -1 over 1. Together, this has to make a -1. Remember, they're opposites. And I'm going to keep the negative in the top because it's always better to have your negative in the numerator than the denominator. So now on the top, I have -3, and that's going to be over x plus 5. Now, if all I have left is x plus 5, do I have to put the brackets around it? No, it actually looks better to not have the brackets, but if I had more than one factor down there, then I would absolutely have to write my brackets. Okay, I'm also going to state my non-permissible values here. So again, I look back to this step. This is where I'm looking for my non-permissible values. And I know from that step that x cannot be -5 or +4. So that is actually part of my answer. So as promised, I'm going to try and circle the whole thing here. So again, that same tip about determining your non-permissible values, that applies before simplifying. Okay, so we've got 3 more on this page and then a word problem to look at on the next page. Okay, so this next question here, it's getting a little bit more complicated. It's testing our factoring skills to see what we remember. Right away though, I do notice that I have a GCF of 2x. Anytime I've got a cube here, I'm getting a little bit suspicious that x is going to be part of my GCF. We haven't really practiced factoring cubes. Okay, so that reduces it back to a quadratic. So I have x squared minus 2x minus 15 on the top. On the bottom, I have a GCF of 4x. That leaves me with x minus 5. So actually the bottom has been factored. It's the top that I need to worry about now. So I'm going to break my trinomial in the top down into two binomials. I'm going to keep the 4x and the x minus 5 in the denominator. So x squared minus 2x minus 15 is going to be x minus 5, x plus 3. Okay, now I want to look and see if there's anything that I can cancel as common factors. So I have my x minus 5s, and those can cancel. They were common, so they give me positive 1 over positive 1. My x can cancel with my x, give me 1s again. My 2 can cancel with my 4, that gives me a 1 on the top and a 2 on the bottom. Okay, so now I've done everything I can. I'm going to write my final answer here. So when I simplify, I have 1, 1, 1, and then just an x plus 3 on the top. So I'm going to have x plus 3 as my numerator. On the denominator, everything's gone except the 2. So my denominator is 2. Now I have to state my non-permissible values. And so there are two of them, a 0 from the 4x and a 5 from x minus 5. Okay, let's take a look at G. So G, the numerator is a difference of squares. So it is factorable as 4x plus 3y times 4x minus 3y. The denominator has a GCF of 2. That's all I can do with that denominator. Luckily, it's creating something that looks quite nice to me. Why does it look nice? Because it completely matches these two factors. They're common, so they're replaced with positive 1s. And I'm ready to write my final answer here of 4x plus 3y all over 2. Now to write my restriction, this one is the hard part of this question. I can't come up with a specific number. It's a relationship that's my restriction. And so in this question, 4x minus 3y, that entire factor, cannot be equal to 0. And that's really the only way that I can write it. So it's not a specific number that's restricted, it's the variable. Pardon me, guys, just trying to figure out how to add a bit more space on my page. I think this, yeah, there we go. Okay, on to our last example like these ones. So we need to try and factor. Now, unfortunately, there's no GCF in the numerator. So it looks like one of those guess and test situations where I'm going to set it up and then see if I can find the right numbers. So I know 3x times x is the only thing that would give me 3x squared. I now have to come up with where to put the 1 and the 3 and which one's going to be negative at the back. I know I'm never going to pair the 3 with the 3 because otherwise I would have had a GCF. So I know for sure if this is factorable, the 1 has to be with the 3x and the 3 has to be with the x. Now the question is, how do I make that negative 8x? I'm going to have to make the majority, which is this one, the 9, the negative. That would give me negative 9 when I multiply these two together. And that would give me positive 1x when I multiply these two together. So there's my x, there's my negative 9x. When I put those two together, I get my negative 8x, which was my middle term. I'm going to erase that because we don't want that to show up in our next step. I need that room to work on my denominator, but that was the guess and test method for factoring that more complicated numerator when the first variable is not a 1. Okay, when I look at the bottom though, happy times, I actually do have a GCF of 3. So that has made my denominator a little bit easier to factor than the numerator. I'm just going to copy my numerator, copy my GCF of 3, and do my factoring. So x squared minus 5x plus 6 factors to be x minus 6 times x plus 1. No, it does not. Sorry, that would give me negative 6. Let me just back it up a second. I got too excited. I'm going to have to try and factor it differently. So it's actually going to be x -2 part and x minus 3. Yeah, because I have to get a positive 6 here. So that gives me my positive 6. Now, one of the ways I knew I had probably made a mistake there is nothing seemed like it was going to cancel. So I'm kind of assuming that there's canceling available to me. Otherwise, I can't even simplify the question. So I do end up with 2 common factors of x minus 3. So those are replaced with positive 1s. Nothing over here can cancel. I cannot cancel this 3 with this 3 because I can only cancel an entire factor, this whole bracket, with an entire factor. And so because this is part of a partnership with the +1, I cannot cancel it with the 3. It's a common mistake that I see people make. So just be aware of that. Okay, so my final answer here is I have 3x plus 1 on top, and I have 3 and then brackets x minus 2 on the bottom. Now I have to state my non-permissible value, so I'm going back and looking at my factor denominator step here. That gives me that x cannot equal 2 or 3. So there's my simplified expression, and there's my non-permissible values. Okay, taking a look at the last question here. This is an application question. So a word problem, in other words, your guys' favorite. Okay, in manufacturing, you often need to know the ratio of the surface area to the volume of a container. Determine the ratio of surface area to volume of a cylinder with radius r and height h. Simplify this ratio and give any non-permissible values of the variables. Okay, so first we have to remember our formulas for surface area and volume. It's probably been a long time since you've done this. Remember, surface area of a cylinder. Think about taking your can opener and going all the way around a soup can. What you would end up with is a circle that gets taken off. Well, you also have another circle on the bottom, and then what's left would be a rectangle if you cut the can and unwound it, or if you take a look at the label on a soup can and peel it off. It's actually a rectangle. So in order to come up with the surface area of a cylinder, we're going to have to account for 2 circles, so that's 2 pi r squared, plus that soup can label. Now, the distance all the way around the soup can label is going to be its length, and that's the circumference, which is 2 pi r, and then times the width, which is the height. So this is really a fancy way of saying length times width, where your length is 2 pi r and your width is h. So that's a bit of a complicated formula, not one that usually people remember, but that one I'm providing it for you. Okay, the volume formula for a cylinder is pi r squared times h. So just the area of the base, which is a circle, times the height. If we want to take the ratio of surface area over volume, I'm going to put my formula for each in there. So I've got 2 pi r squared plus 2 pi r h on the top, and I've got pi r squared h on the bottom. Now, I want to treat this like the questions that I just did, so I'm going to factor a GCF out of my numerator. So my GCF is 2 pi r. That leaves me with r plus h. In the bottom, it's already factored as pi r squared h. Now I'm going to reduce whatever I can. So they both have a pi that can be reduced. They both have an r that can be reduced, although here I'm still left with an r. So the simplified version of the ratio of surface area to volume for a cylinder is 2 times r plus h all over rh. Now I have to give my restrictions. In this question, r can't equal 0 and h can't equal 0. And those are coming from looking at any of the steps of the denominator. But you can see here, if you had a 0 for the r or a 0 for the h, it would make your whole denominator equal to 0. So there's my answer for that one. Word problem number 2, create a rational expression in which x cannot equal 2 or 3. Well, that's fairly simple. You could literally have anything you want on top. So write any kind of expression you want on top, make it as simple or as crazy as you want. And then on the bottom, I would not be able to have x minus 2 or x minus 3. That's the simplest example, because if I put a 2 in there, I would get 0. If I put a 3 in this one, I would get 0 again. So that's the simplest rational expression I could create. You could get more creative than that, but that's where I'm going to stop with that one. Number 3. Create a rational expression that is equivalent to x minus 8 in which x cannot equal 1. Okay, so if x can't equal 1, that means I'm going to make my denominator x minus 1. Now, I want it to eventually equal x minus 8, equivalent to x minus 8. So I want my answer to equal that. Well, that means I must have an x minus 8 somewhere in my question, and I must have canceled my x minus 1. So what's the answer to this question? Oops, pardon me. The answer to this question is my original question that I came up with. Okay, let's take a look at this last one. Is the following work correct? This is something that I see in a lot of students' work. So can you find the mistake, or is it okay? So somebody had an expression of x plus 10 over 10. They canceled the 10s and told me that that was just x. And that is a big and common mistake. And here's why. You can only cancel entire factors with entire factors. You cannot cancel terms. You can cancel factors. So here they cancel the term of 10 with a 10. No, x plus 10 is together as a factor. Okay, so just be careful when you see stuff like that. It's tempting to just knock off numbers, but because this was an addition sign, x plus 10 is together. So even though you can't see the brackets on that, it is a binomial, it's connected, and so the brackets are almost considered to be invisible on a question like that. Okay, so that is our first lesson for this unit. This is 6.1. All the examples have now been completed, and you should be able to work on your homework assignment from the textbook for 6.1. It's the same homework that I assigned on that homework sheet at the beginning of the year. If you've lost that sheet, it is posted on the Google Classroom, so you should be able to find it there. And if you don't have your textbook, that's fine. I've posted a link on the Google Classroom where you can find the textbook online. If you happen to still have your textbook because you didn't give it to the library, that's actually great. You can work on it with your paper copy of your textbook if you're lucky enough to still have it. Okay, I will finish this video up, and then I will be posting one for 6.2 shortly. Have a good day.